Hello. Today we'll be talking about specific heat capacity. And the specific heat capacity of substances is the amount of energy that a substance could hold, withhold, release, and regardless of the substance, they have different capacities. And one of the most famous one is water. That's the one we use most of on these equations. Okay, the question is energy in joules equals specific heat capacity times the mass times the change in temperature. Regardless of the change, positive change or negative change, a change is just a number. Okay, not positive nor negative. So we go energy in joules equals specific capacity times the mass in grams of the substance and the change in temperature. These numbers are based on tables that they have studied and they have determined the capacities of the substances. Make sure that whatever table you use, you're using joules, grams, or Celsius. If the table doesn't give it to you in joules, grams, or Celsius, then you need to convert your factors to variables so that the table matches those numbers. So we'll be looking at joules, grams, Celsius table. And the question says, when 3 kilograms of water, okay, let me make that into grams. So I get 3 kilograms times 1,000 gives me 3,000 grams. That's the amount of water. When 3,000 grams now is cooled from 80 to 10 degrees Celsius, the change is 70 degrees. How much energy is lost? So if I look at the equation above, I do have the mass, I do have the change in temperature, but I don't have the specific heat nor energy. Well, the specific heat capacity of water is given on a chart, given on the table, and the value is 4.184. So I have now all my variables. I have the water, 4.184 specific heat capacity of the water. That'll be joules, grams degrees Celsius, times the mass, which is 3,000 grams, times the change in temperature, which is 70 degrees Celsius. And I could just cancel my variables by doing this. Grams cancels grams and Celsius cancels Celsius. Therefore, when I multiply 4.184 times 3,000 grams times 70, my answer becomes to be, or comes to be, sorry, 8.79 times 10 to the fifth joules. And joules is the only unit that I didn't cancel. Let me go back to this equation above. Based on this equation, I could work any number that I want to. Okay, I could work out specific heat of the substance. I could work out energy. I could work out mass. I could work out change in temperature. It all depends on what the question asks you. Let me go back to this other sample question here. Based on the above equation, if a substance has a mass of 20.1 grams, releases an amount of energy of 78 joules, and changes its temperature by 50 degrees Celsius, they're giving you the change. It changes by 50 degrees Celsius. What is the specific heat capacity of the substance? Okay, so if I look at the equation says energy equals specific capacity of the substance, and I have times the mass, and I have times the change, delta T, change in temperature. Let me work that out. I do have the energy, which is 78 joules, and I will divide that now by my mass, which is 20.1 grams, times my change in temperature, which is 50. The only thing left here is the specific heat capacity. When I divide 78 divided by the multiplication of 20.1 times 50, it comes out to be 7.76 times 10 to the negative 2. In this case, I cancel no units, so it is joules over grams degrees Celsius. Regardless of the question, your job is to make sure that you know what you have and you know what you need to look for. Back to the top equation. If I need to look for the change in temperature, I will leave that alone. Energy is always on top. Bring this down, bring this down. What you have now is energy divided by the specific heat capacity divided by the mass. This would give you change in temperature. Let me go back over here now, the original. If I need to look for the final temperature or initial temperature, okay, you need to play with those variables, leaving either the final or the initial temperature alone.